So far, what we've done is we've gone from words to symbols, symbols to words. And then we looked at determining whether compound statements are true and false by using a truth table. Now, again, I'm going to remind you that when you're in the English language, when you're looking at words, sometimes it's difficult to tell whether things are true or false. Sometimes it's difficult to tell whether statements have the same meaning. So once we can translate that to symbolic form, then it's easier to tell true and false or whether statements have the same meaning. So that's what we're going to do in this section. We're going to look at what we call equivalent statements. And we're going to use these 3 bars. These 3 bars are similar to an equal sign. Now we don't use an equal sign because statements are equal if they're exactly the same. But equivalent just means that they have the same meaning. So they could be made up of different words, but they have to have the same meaning. And when we say they have the same meaning, what that means is they have the same simple statements and same truth value for all possible combinations of true and false. Right now, that's probably just a bunch of words. So what we're going to do is demonstrate this by using example 1. In example 1, we want to show that these statements are equivalent. So part A, we have P or Q. If not Q, then P. So are these statements equivalent? Do they have the same meaning? Well, first of all, do they have the same simple statements? So same simple statements means, are they made up of the same letters in symbolic form? And yes, they are. They're both just made up with P and Q. So they do have the same simple statements. So the next thing we want to do is we want to check their truth value. Do they have the same truth values for all possible combinations of true and false? So what we're going to do is we're going to construct a truth table. We have P, we have Q, and then P, true, true, false, false. Q is true, false, true, false. So the idea is to put P or Q, if not Q, then P, put them both in the truth table and compare them. When I look at P or Q, I already have P listed and I already have Q listed, so I can determine the truth value for P or Q. So true, true is true. True, false is true. False, true is true. False, false is false. Now I'd like to put if not Q then P in the truth table to compare them, but I don't have a not Q listed, so I need to figure out that first. So again, if Q is true, false, true, false, not Q is the opposite, false, true, false, true. I can now figure out the conditional statement, if not Q then P. So remember with the conditional statement, the order matters. And here we're going from not Q to P. So we're going false to true in a conditional statement is true. And then we're going true to true, which is true. False to false, true. True to false is false. This is where we're going to compare them. Okay, so we're going to be comparing P or Q with if not Q then P. Notice that if we go down, we have a true, true. They match. True, 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 false, false. So that's what it means in the definition when it says the same truth value for all possible combinations of true and false. What it means is put those statements in a truth table and compare them. If they match up true, false all the way, they're equivalent. So how we would write this is P or Q is equivalent. So we use those 3 dashes to if not Q, then P. So word-wise, they won't be exactly the same, but what this means is these 2 statements have the same meaning. In part B, it says use the result from part A to write a statement that is equivalent to I am sad, or the campus is closed. So let's look at part B. I am sad, or the campus is closed. So here P can be the statement I am sad, and Q can be the statement the campus is closed. So this statement in symbolic form is P or Q. And I know that that's equivalent to, if not Q, then P. So that would be if not Q. So if the campus is not closed, then I am sad. And that would be using this idea of equivalence to write the statement in an equivalent way. So notice if you look at I am sad or the campus is closed, and then look at if the campus is not closed, then I am sad. It's hard to tell when it's in words that these actually are equivalent statements, but once we're in symbolic form, we can prove that they're equivalent. We're going to move on to the next example of how we can use the truth table. In example 2, this time we want to select the statement that is not equivalent to, if it is sunny, then I will go to the beach. So you have to be careful when you're on My Lab that you're reading the directions correctly. Sometimes it'll ask you to show equivalent. Sometimes it'll ask you to choose not equivalent. Well, what I need to do first, since I'm going to use a truth table, is translate to symbolic form. Here I have an if-then. Oops. I'm going to let P be it is sunny. And then Q is going to be I will go to the beach. Okay. So I have my statements P and Q. My original statement is if P, then Q. So this would be P arrow Q. Since I'm going to be using a truth table to determine the statement that's not equivalent to if P, then Q, that means I have to translate statements A, B, C, D into symbolic form. A, it is sunny, or I will go to the beach, or it is not sunny, sorry. So that would be not P, or I will go to the beach is Q. And then B is I will go to the beach, or it is not sunny. So I will go to the beach is Q, or it is not sunny would be not P. If you look at A and B, they're kind of the same, right? Because or, it doesn't matter the order. Did you write the not P and the Q? They should have the same truth value. So I can see that A and B are actually equivalent to each other. C, if I go to the beach, then it is sunny. So that's if I go to the beach is Q. So if Q, then P. So Q arrow P. D, if I do not go to the beach, then it is not sunny. So I do not go to the beach is not Q. So that's if, not Q. Then it is not sunny would be not P. I can see that they're all made up of the simple statements P and Q. So I'm going to fill in my truth table now. P is true, true, false, false. Q is true, false, true, false. So the first statement that I'd like to put in is my original statement. If P, then Q, because I want to compare all of these 5 statements. Let's see, so we have true, true is true, true, false is false, false, true is true, false, false is true. So not P or Q, I don't have a not P listed, so I'm going to put in not P. If P is true, true, false, false, not P is false, false, true, true. So if not, or I'm sorry, not P or Q. So again, I'm only looking at not P on one side of my or and Q on the other. So I have a false, true is true. And then false, false is false, true, 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 and then true. So that should be a true, false, true, true. So far, that is equivalent to my original statement. Remember, the question was, which one is not equivalent? So if I simply change the order around, and this would be the statement in part B to write Q or not P, it's going to be the same. It's going to be true, false, true, true. So again, this statement is equivalent to my original statement, if P then Q. So let's do if Q then P. So remember, we're starting at Q, which is true, false, true, false. And then we're going to P, which is true, true, false, false. So we have a true to true is true. False to true is true. And I can stop. I don't even have to fill in that column because already I can see by this second value here that it's not the same as my original statement. So I can already tell that that statement is not equivalent to my original statement. But let's go ahead and finish this off just for practice. Then we're going to have a false, because not P is, or Q is true and P is false. So it's going true to false is false. And then false to false is true. The question said select the statement that is not equivalent to if P then Q. And I found the statement that's not equivalent. Maybe there's more. I don't think so. But we'll go ahead and finish off our statement in part D. I'm going to need a not Q first. So Q is true, false, true, false. Not Q is false, true, false, true. If not Q, then not P. So this is true because we're going false to false. And then true to false is false. False to true is true. True, true is true. So this statement is equivalent to our original statement. So the only statement that is not equivalent to if P then Q is this if Q then P. And then that would be C. If I go to the beach, then it is sunny. So that is not equivalent to if it is sunny, then I will go to the beach. Which brings us to variations of our conditional statement. So again, remember, we have to be careful with conditional statements because the order matters. So conditional statement, every conditional statement is equivalent to what we call its contrapositive. And what the contrapositive does is it switches the order of your statements and it negates both pieces. So if your conditional statement is if P then Q, it will be equivalent to flip it and negate. So if not Q, then not P. These are equivalent. And you could prove that by putting them both in a truth table and showing that they match up true and false all the way down. What we're going to do in example 3 is we're going to write the contrapositive for each of the following statements. A, if you are driving, then you are not walking. So for part A, you could change it to symbolic form if you wish, but this is an if-then. Remember what we're doing here. We're changing the order. So one way to remember that is flip and then negate. Or you can say switch and negate. My simple statements, you are driving, you are not walking. So I'm going to flip it. It'll be if you're walking, then you are not driving. So you're going to switch your statements and you're going to negate each piece. So this becomes if you are not walking becomes you are walking. Then you are driving becomes you are not driving. Okay, so if you're not sure how to write the contrapositive and keep it in words, if it's given to you in words, then you can change it to the symbolic form. You can switch and negate both sides and then translate it back into words. Part B, if you do not eat, then you will starve. So again, this is if, then. You do not eat, you will starve. So we're going to switch the order. The if then stays, right? We're not switching that. We're just switching the simple statement. So the if you will starve becomes you will not starve. If you will not starve, that sounds kind of weird. So I'm going to grammatically change it to if you do not starve. It just sounds better. So if you do not starve, then you do not eat becomes you eat. I'm going to write you will eat. Or you eat, it's fine. That's a good C. So C, our statement was given in symbolic form, so our answer is going to be in symbolic form. So typically in mathematics is the way that you are given the problem is the way that you should write the answer unless you're told otherwise. So notice that this is a conditional statement. We have our arrow here. So my job is to change the order. So now the R is going to be in front, but I'm going to negate it. Arrow. And then I'm going to negate the negation of P and Q. Okay, so again, all I did was I switched the order and then I negated both sides. But that double negative in mathematics, they can cancel. So more simply, and you didn't have to write that step, you could have gone to if not R, then in parentheses, you still need the parentheses, P and Q. We know that a conditional statement is equivalent to its contrapositive. Here are some other properties that we have with conditional statements. So a conditional statement, and we're looking at the generic if P then Q. And then we have a column for the English, if P then Q, if you're saying it. We know that it's equivalent to its contrapositive, which is if not Q then P. So these two, oops, don't want the thick one. These two are equivalent. But now we also have what we call a converse. So the converse says you take the original conditional statement, if P then Q, and you just change the order, but you do not negate both sides. So converse, think about a conversation going back and forth, is just switching the order. Inverse says you take the original conditional statement, if P then Q, and you keep the order the same, but you negate. So if not P, then not Q. It turns out that the converse and the inverse are not equivalent to the conditional statement. However, the converse and the inverse are equivalent to each other. So conditional equivalent to its contrapositive, converse equivalent to the inverse. We'll look at our last example in this section, and this is not a very long section. Example 4 says write the converse, inverse, and contrapositive for the statement. If you live in Hawaii, then you don't have a state lottery. So this is an if then. I have my statements. You live in Hawaii, you don't have a state lottery. Let's first write the converse. So if I were to write the converse, remember the converse says you change the order but you do not negate. So it's going to be if you don't have a state lottery, then you live in Hawaii. And I can already see that this converse is not equivalent to the original statement. So the original statement, if you live in Hawaii, then you don't have a state lottery. That's actually a true statement because Hawaii doesn't have a state lottery. But look at the converse. If you don't have a state lottery, then you live in Hawaii. Well, that's not true. There are other states that don't have a state lottery. I wonder if Washington does. I know there's a few. So you could live in a state that doesn't have a state lottery, and you would not be living in Hawaii. So again, these are not equivalent. Let's look at the inverse. So remember what the inverse says is that we're going to negate, but the order is going to remain the same as our original statement. So if you do not live in Hawaii, then you don't have a state lottery is you have a state lottery. All right, so compare it to our original statement, and you could see that they don't have the same meaning. So the inverse, if you do not live in Hawaii, then you have a state lottery. Well, that again is not true. You could live in another state and that does not have a state lottery, which makes the inverse false. Our contrapositive says that we're going to switch and we're going to negate both. So it's if you don't have a state lottery becomes you have a state lottery. So if you have a state lottery, then you live in Hawaii becomes you do not live in Hawaii. Okay, notice that that actually is true. So if you do have a state lottery, then you can be living in Hawaii because Hawaii doesn't have a state lottery. So again, this contrapositive is equivalent to our original statement. However, the contrapositive and the original statement are not equivalent to either the converse or the inverse. This is it for 3.5. It's a fairly short section. It's just exploring truth tables further and then discussing this idea of equivalence.